So here's your last rules for finding derivatives, and then we're going to talk about how you use them. The derivative of natural log of x is y prime equals 1 over x. The derivative of arc sine of x is 1 over square root of 1 minus x squared. A trick on that one, the way I remember arc sine, it has an s in it, and it also has a square root. It also has a subtraction sign. So all the s's stay together. Arctangent, the derivative is 1 over 1 plus x squared. It has a plus that looks an awful lot like a t. So I don't know if that really will help or not, but that's sort of a trick that helps you remember it. Arc sine has a square root and a subtract sign. Arctan has a plus that looks like a T. But that's the last three rules you need to know. So let's talk about some examples of how you use them. Alright, so the derivative of this, we know that the derivative of natural log is 1 over x, or in this case 1 over whatever its natural log of, but then you multiply by the derivative of whatever you were taking natural log of. So I multiply by 2x. And you could write that as 2x over x squared plus 1. Okay, the derivative of natural log of x over x plus 1. So the derivative of natural log of something is 1 over the something times the derivative of the inside. So here, I'm trying to find the derivative of this. I'm going to have to use the product or the quotient rule since it's a quotient. So the bottom times the derivative of the top is 1, minus the top times the derivative of the bottom, which is 1, over the bottom squared. Now, 1 over a fraction, you can just take the fraction and flip it. You could have done 1 times and then flip the second one to see it, but that's what happens there. And then here we get 1 over x plus 1 squared. One of these will cancel, and we'll get 1 over x times x plus 1. Alright, here's another one. It's a natural log of e to the 10x. I want to tell you that there's a couple rules about natural logs that you may or may not remember. One of the rules says if you have natural log of e to something, that you can bring your power down in front of the log. It's the power rule for exponents. So this is not the derivative, that's just another way to rewrite it. I know that natural log of e is 1, so really y is just 10x. So now if I want to find its derivative, I get 10. Another rule about natural logs and e's, anytime you have e to the natural log of something, it always equals something. And then you find the derivative. The derivative of x is 1. So that was some more rules about natural logs. Alright, so we have e to the ln of something. Well, that means equals the something. So then to find the derivative, I just get 2x. Alright, here's another natural log. I know it's 1 over whatever that is. And then I multiply by the derivative of the inside. So the derivative of sine of something is cosine of something times the derivative of something, which is 1 minus 2x. You could put that over here on top of the sign if you wanted to. I'm okay with that answer. I just want to tell you, though, that it is possible on a multiple choice that you would see something like cotangent of x minus x squared times 1 minus 2x. It's possible you'd see something like that because that's a cosine over sine, and cosine over sine is cotangent. Alright, here's our arcsine and arctangent rules. So the rule about arcsine is that it's 1 over the square root of 1 minus x squared, or whatever's in parentheses, squared. So that's going to be x squared minus 1 squared. And then I multiply by the derivative of x squared minus 1, which is 2x. And it's okay to leave it that way. You could maybe multiply something underneath the square root, but it's okay. And that 2x, you can put it on top if you want to. Alright, arctangent. So the derivative is 1 over 1 plus that squared. And then you times it by the derivative of square root of x, which is 1/2 x and negative 1/2. This one, simplified, would be 1 over 2 square root of x times 1 plus x, because square root of x times square root of x is x. And that's on the bottom, and then that comes to the bottom because of the negative power. Arcsine of sine. So the derivative of arcsine of sine is 1 over square root 1 minus whatever its arcsine of squared times the derivative of arcsine, or times the derivative of sine, which is the inside, which is cosine of x. Now, I want to tell you that this will simplify. 1 minus sine squared of x is the same as cosine squared of x. And that comes from that Pythagorean identity I showed you last week. The square root of cosine squared of x is cosine of x, so you get cosine over cosine, which is 1. Now, you really don't have to do that whole process. I just wanted to sort of show it to you just so you could get more practice with arcsine. What you need to know is that arcsine and sine sort of cancel out. It equals x. The derivative of x is 1. Because it's kind of saying, find the sine of an angle and then find the angle that makes that true. So it's just going backwards and ends back up with what you started with. I will also tell you, if you have sine of arcsine of x, same process is true. That still equals x, and then you can find the derivative. Alright, here's arcsine of cosine, and since those are different, we're not going to use that process. We're just going to practice with arcsine. So we're going to say 1 over the square root of 1 minus cosine squared of x times the derivative of cosine, which is sine. I'm okay with that answer. You probably can simplify it. It would simplify to, alright, this would be sine squared of x. Square root of sine squared is sine. This is a negative. I forgot to do that. The derivative of cosine is negative sine. And again, we get negative 1. So just another way to think about it. Here's 4 try problems. ln of 2x minus 3, arcsine of x squared minus 1, arctan of e to the x, and natural log of x times sine of x. I'm going to rewrite that last one. That is not a power like it looked like. And then finish your trig homework from the previous day.